In this video, I'm going to introduce you to linear relationships. This is when algebra becomes truly powerful. This marks the beginning of a long journey into how we can model relationships. So I want to ask you, what makes a relationship linear? This isn't a rhetorical question. What do you think? Well, what makes a relationship linear is if there is a constant rate of change. So we can define it as a pattern where there's constant rate of change. And I'm going to give you a very useful example. A pattern with a constant rate of change. Constant rate of change. So now, and just to get the elephant out of the room, or address the elephant in the room, this is when we start working on this, the XY coordinate plane, or the Cartesian plane. But we'll get to that shortly. So I just defined what makes a relationship linear. It's a pattern with a constant rate of change, with an E. Constant rate of change. So let me give you a very important example. Let's suppose you earn $20 an hour. $20 per hour. Suppose you earn $20 per hour. Well, I bet you know what that means if you were to work 2 hours or 3 hours. But how do you think we model that? Well, we model it in two ways. We model it with tables and charts. So we would create a table that has hours, the hours you work, which we'll put a little X beside it, and pay, and we'll put a little Y beside it. And if you were to work 1 hour, we would say you were paid $20. And if you were to work 2 hours, you would be paid $40. And if you were to work 3 hours, you would make $60. And this is a constant rate of change, you'll notice. For every X that increases, for every hour that increases by 1, your pay increases by 20. And then you increase another 20 over here for your pay, you're going to increase another hour over here. A constant rate of change. Okay, and furthermore, we model that with tables, but we can actually model that on charts as well. But first, before we hit the chart, before we go into the chart, I want to make one more distinction for you. So we have two types of variables: independent, and we'll just abbreviate this. Indep. That's what we'll abbreviate as. Independ. And we also have, let's go green for this one, and we also have dependent. Depend. So we have independent and we have dependent variables. Now, which one do you think is independent and dependent? Well, the independent variable is your hours, okay? Your hours in this case, or X. Whereas your dependent value is your pay, also known as Y. So why is X independent and Y dependent? Well, because that's the convention that we've come to. But really, what's one reason, but when you really think about it, the hours change one. They change one at a time. Whereas the pay changes by a preset value. So the more we change X, 1, 2, 3, Y could change 20, 40, 60. Or let's say you got a raise, you went from 20 to 25. Well, Y is now a different, or pay is now a different, uh, different variable, so to speak. Okay. Now, I don't want this to come on too strong for you. I don't want you to lose sight of this. That this is something you understand. Like, I'm sure you understand this intuitively, and if you don't, you will very soon. So we can actually, that table can be expressed one more way, and then we're going to graph this relationship. And the other way this table can be expressed is by this: Y equals 20x. Okay? Y equals 20x. Let's rephrase that. Pay equals 20 times hours. So if you worked 2 hours, you would be paid $40. So now what we've done is formalize the linear relationship here. And now we're going to tackle the final step. And that step is going to be graphing the equation. Okay? So let's graph. Let's make it green. Okay, we're going to make it green. Right? And we're going to put 1, 2, 3, 4. We're going to put 4 hash marks. And each hash mark represents a point along 20, intervals of 20. 20, 40, 60, 80. And we're going to put 1, 2, 3, 4. We're going to put 4 marks here. The first mark is 1, 2, 3, and 4. Okay, along your x-axis, this is your x-axis. Along this axis is your hours worked. Okay? That's the left side of this column, or this left column. And now along what we call the y-axis, this vertical axis, this is your pay. This is your total pay. All right, now let's take a look at how we graph this. Okay, well, we move over. We start at 0. You have 0 hours worked and $0 earned. And then we move along the x-axis. We can imagine this is 1 hour passing while you're at work. That 1 hour is passed, then we move up by 20 for our pay. And right about there, we put a mark. Okay, now another hour passes. You've been at work for 2 hours. Now from there, we travel up to about we travel exactly to where the 40 mark is. You can imagine if you were on graph paper, this would come out perfectly clean. You would have all these intersections, but now we move over another hour, And now we've earned an additional $20, more than 40. So we travel right up to about 60. We mark it. And let's stop there because that's where we stopped on our table. Now, what we have here is a linear equation. This green mark was a little bit off, or one of the green marks was a little bit off. But this represents our purpose here. This is good enough for our purposes. So if you look, now remember, a linear relationship is a pattern with a constant rate of change. And this has a constant rate of change. And actually this line actually should extend to 0. Because remember, when we were at 0 hours, and I'm sorry, but I've got to clean this up a little bit. So we're more like right there. 3, we're more like right there. Okay. Let's try that on for size. Okay. The point, I don't want to lose sight of the point here. When I do this in the future, it'll be on a graphing website or graphing paper more so. But our point is, for every 1 hour that passes, we create a line. Because the rate of change, because every change in x has an equivalent change in y, we change an hour here, we go up another 20, we change an hour here, we go up another 20. You can see it's like a stair step. It creates like a stair step pattern where we go over 1, up 20, over 1, up 20, over 1, up 20. And this is going to continue on and on and on. So we've created, and since it's in a consistent slope, it's the same change, you basically create a straight line that will stretch on for infinity. And that's the incredible power of algebra, because now, once you understand this, if you had an x of, if you had worked 100 hours, you could figure out that you made $2,000. You can figure out that you made $2,000. But furthermore, if you worked 111.3 hours, you could figure out what your y value is. Okay, any value you could solve. That's the power of these relationships. So I hope all of that made sense to you. What I'm going to set up is a set of practice questions, and they'll be more about creating tables and identifying linear relationships this time, rather than crunching the numbers. So let's get into the practice. We've gone over all of this. We understand what makes a relationship linear. We understand a pattern, that it's a pattern with a constant rate of change. We know that if you earn $20 per hour, we could place it in a table like this. We learned the difference between the independent variable and the dependent variable. And actually, one thing I just want to rehash is that I want you to understand the x and the y. The x is the x in this case is representing your hours. and you know what your pay rate is. So think about how those fit together and realize that your X is going to be things like your hours worked, uh, time passed, things like that. And your Y is going to be values like distance or um, total. These are examples. That's why it's your dependent variable. Now this time for your practice, it's going to be a little bit different. I set you up a problem here. It's going to take up a little more space, so we're going to do this one at a time. This question says that a job pays $12 per hour, and I want you to create a table which represents this. Go ahead and give it a try. Okay, so we're told that we pay, let's break this down, $12 per hour. Okay, so we know he gets paid $12. All right, so which of $12 and 1 hour, which of these are dependent variables and which of these are independent variables? Well, the independent variable is 1 hour, independent. And your dependent value is 12. And if you'll remember, the dependent is your Y and the independent is your X. So now we create your table. We put X on one side, or we could say hours. X represents hours. You won't see it like this for long, but we can do it this time. Y equals total pay. Total pay. But Y will represent your total pay. Okay? So when we work 1 hour, our total pay will be $12. And when we work 2 hours, actually, let's take it one step back. And if you didn't put exactly this, that's okay. This is more of a conceptual lesson. So when we're at 0 hours, what is our total pay? Well, it's $0. When we're at 1 hour, it's $12. And remember, Y equals 12x. Okay? That's how I'm solving this. So Y equals 12x. So when we have 2 hours, it equals Y equals 12 times 2. So 24. All right, then when we have 3 hours, okay, Y equals 3 times 12, which is 36. All right. So you may not have created exactly this, but hopefully you understood which goes where. I could have given better direction on that to tell you exactly what to graph, but that's okay. It's a conceptual lesson. Now we're going to move on to a problem where you analyze a table and tell me if it's linear relationship or not. Okay, moving on to analyzing a table. All right, our question asked, does the following table represent a linear relationship? And what I want you to do is analyze this table and answer yes or no. Does it represent a linear relationship? Okay, so how do we approach analyzing a table? And now, this is a very conceptual thing. If this is something you're familiar with, you probably got it in the blink of an eye. If you're unfamiliar with it, it may feel very alien, and rightfully so. But this is how we approach it. So x is our independent value. So it has a constant change here. It's plus 1, it's plus 1, it's plus 1 each time, okay? Let's clean that up a little bit. It's simply plus 1 every time. That's our independent variable. Okay, let's analyze on under the y column. What is the difference between 4 and 8? If you're unsure how to find that and that relationship's not making sense, 8 minus 4 is our difference which is plus 4. Okay? It sounds exactly like what we say. The difference. So what's the difference between 12 and 8? The difference is 4. Okay, so right here, what are we seeing? Why? What is this? Is it a linear relationship? Yes, it's a linear relationship because it is a constant rate of change. A constant rate of change. Rate of change. So the rate of change is for every 1x we increase by 4y. So when you go up 1 in the x column, you go up 4 in the y column. And this pattern, once you see this pattern repeat 3 times, you can safely assume that this is, or you can conclude that this is the pattern that a linear equation will follow. And you can graph it. So let's move on to the third question. We're going to analyze another table, and I want you to analyze this and determine if it represents a linear relationship. Okay. Let's repeat the process. Repetition is key. So our independent variable over here is increasing by 1. What does our dependent variable do here? So 3 to 7 is plus 4. And 7 to 15 is plus 8. Okay, so that tells us right there, no, it does not represent a linear relationship because we had a non-constant rate of change. Non-constant rate of change. That's why it's not a linear relationship. So now that was a lot. There was a lot of content, but this is the introduction to linear relationships. And this sort of stuff that we just did is the very foundations of so much of algebra. So we're going to do a ton of this, and it's really a quite fun thing to do. And you get to see some very interesting properties about mathematics, learning this kind of thing. If you got some value out of this video, please like, subscribe, or leave a comment. Have a good day.